All right, let's dive right in. Today we're going to demystify one of the most beautiful and honestly powerful ideas in all of mathematics. And we're going to do it by starting with a question that seemed totally impossible to answer for centuries. For centuries, this one simple question just stopped mathematicians in their tracks. Think about it. Any real number you can imagine, positive, negative, doesn't matter. When you square it, you get a positive result. So how on earth could you find a number that, when multiplied by itself, gives you -1? It seems like it just can't exist. So, what do you do with a problem you can't solve? Well, in this case, mathematicians did something brilliant. They invented a solution. They just defined a brand new number. They called it I for imaginary, and they gave it one simple, revolutionary job: to be the square root of -1. It's a whole new tool for our toolkit. But here's the thing. I isn't just some clever little algebraic trick. It's so much bigger than that. Its creation literally opened up a whole new dimension for numbers. Just picture our good old number line. It's flat, right? You can go to the right for positive numbers, to the left for negative numbers, and that's it. It's basically a one-way street, forward and back. There is simply no room on this line for a number like I. So what's the fix? Well, we do something kind of mind-bending. We add a new dimension. We keep our horizontal line for all the real numbers we know and love, and we add a vertical axis for our new imaginary numbers. And just like that, boom, we've created a two-dimensional map called the complex plane. And what's so cool about this new map is that it lets us plot any complex number, which is just a fancy name for a mix of a real part and an imaginary part. So a number like 3 plus 4i isn't some weird abstract thing anymore. It's just a location on the map. You go 3 steps over on the real axis and 4 steps up on the imaginary axis. Every single complex number has its own unique spot on this plane. Okay, so now that we have this map, just like telling someone how to get to your house, there's more than one way to give directions to a point on this new complex plane. We've basically got 2 different languages we can use here. The first one, rectangular form, is what we just did. It's like giving directions in a city. Go 3 blocks east, then 4 blocks north. Simple enough. But the second one, polar form, is more like just pointing. It tells you 2 things: how far away it is in a straight line and at what angle you need to turn. Right, and these 2 pieces of info have their own special names. That straight line distance, r, we call that the modulus. And you can find it super easily with the Pythagorean theorem. You probably remember that from school. And the angle, theta, that's the argument. It's really just the direction you're pointing. Now, switching from one form to the other is pretty straightforward, but there is one little catch you have to watch out for. Your calculator might spit out an angle, but it could be pointing in the completely wrong direction, the wrong quadrant. So you always, and I mean always, want to just quickly picture where that point is on the plane to make sure your angle actually makes sense. Okay, I know what you might be thinking. This is neat and all, but why? Why do we need a whole second way to write these numbers? And that is an excellent question, because this is where the real magic happens. This is where we get into rotation, which, it turns out, is absolutely fundamental to things like engineering and physics. See, back in that rectangular city grid form, adding and subtracting is a piece of cake. You just deal with the real parts, then the imaginary parts. But multiplying? Oh man, it gets messy. It's a bunch of steps, and when you get the answer, it doesn't really give you any good intuition for what just happened geometrically. But the moment you switch over to polar form, all that mess just vanishes. Multiplication and division suddenly become incredibly simple, elegant even. Just look at this. This is so cool. To multiply 2 complex numbers, you just multiply their distances, their magnitudes, and you add their angles. That's it. To divide them, you divide the distances and subtract the angles. What was this clunky algebraic mess is now a really intuitive geometric act of just stretching and rotating. And this beautiful simplicity, it is not a coincidence. It's a huge clue that there's some deep hidden connection between rotation and something else. And that leads us to one of the most remarkable formulas in all of mathematics. The famous physicist Richard Feynman, he called this relationship our joule. And trust me, he was not exaggerating one bit. And here it is, Euler's formula. Now, at first glance, it looks pretty abstract, but what it's doing is building this unbelievable bridge between 2 areas of math that seem to have nothing to do with each other.
On one side, you have e, the number that defines exponential growth, and on the other, you have cosine and sine, the functions that describe waves and rotation. Euler's formula tells us that imaginary exponents are secretly just about rotation. This is the joule.
So what this lets us do is take that whole clunky polar form, that r times cosine theta plus I sine theta thing, and rewrite it in this beautifully compact way. Z equals r times e to the I theta. This is the form you'll see everywhere, in physics, signal processing, electrical engineering, everywhere.
So, let's step back. What's the big takeaway here? We started with a question that seemed impossible, right? And it led us to a whole new dimension for our numbers. We saw that looking at things from a different angle, the polar form, showed us that multiplication is really just a form of rotation. And then we landed on Euler's formula, which ties all of it together in one of the most profound ideas in science. And this isn't just theory. These are essential tools that build our modern world.
And it really makes you wonder, doesn't it? If a connection this beautiful, this deep, was just hiding right under our noses the whole time, what other incredible connections, what other hidden truths are still out there, just waiting for us to find them?